The central history of today's security zeitgeist is the American development and deployment of fifth-generation stealth aircraft like the F-35 Lightning. However, behind the scenes, numerous governments are already planning the design of a sixth-generation jet. The latter include France, Germany, and the United Kingdom is talking up a conceptual sixth-generation MiG-41 interceptor. And currently, the United States also has two projects. The Air Force's Penetrating Counter-Air, a long-range stealth fighter to escort stealth bombers, and the Navy's F-A-20. Moreover, Boeing, Lockheed Martin, and Northrop Grumman Company have also unveiled sixth-generation concepts so far. Many of the technology used in the various sixth-generation concepts are quite similar. The stealthy aircraft and long-range weapons that distinguished fifth-generation fighters will remain fundamental to the sixth-generation fighters. Stealth aircraft must be capable of penetrating anti-access or area denial bubbles and eliminating air defense from a safe distance. In addition, in aerial war scenarios, stealth jets also outperform non-stealth aircraft significantly. Thus, low radar cross-sections and radar-absorbent materials will be necessary but insufficient feature of sixth-generation fighters. According to some theorists, the enhanced sensor technology will eventually render stealthy airframes obsolete, and that stealthy airframes cannot be modified as easily as avionics and weapon. Therefore, jamming, electronic warfare, and infrared obscuring countermeasures will all become more important as a result. Beyond visual range missiles also will remain a key technology. For instance, the extent missiles like the AAM-120D can already hit targets over 100 miles away, but realistically must be fired much closer to have a good chance of a kill against an agile, fighter-sized target. Moreover, new ramjet-powered high-speed air-to-air missiles like the British Meteor and Chinese PL-15 point to why future air warriors may mostly fight at great distances from their adversaries. F-35 fighter jet, however, has pioneered powerful helmet-mounted displays that can see through the airframe for better situational awareness, display key instrument data, and target missiles via a helmet-mounted sight. Though these helmets are still in the early stages of development, they are expected to become a standard feature in future aircraft, possibly replacing cockpit instrument panels. The sixth-generation jets differ from the fifth-generation jets in that they have larger airframes and more efficient engines. As airbases and carriers become more vulnerable to missile attacks, warplanes will need to be able to fly longer distances and carry more armaments, which is challenging when a stealth relies primarily on internal fuel tanks and weapons loads. The natural solution is a larger airframe. As air forces expect within visual range aerial dogfights to be infrequent and possibly mutually suicidal, they are showing a greater willingness to trade off maneuverability in favor of higher sustained speeds and a larger payload. These design goals may align well with the development of advanced adaptive G-variable cycle engines that can change their configurations in mid-flight to perform better at high speeds or save fuel at low speeds. Moreover, the sixth-generation jet is optionally manned. For decades, air power theorists have predicted a shift to crewless combat jets, which will avoid the increased weight and risk to life and limb that a human pilot requires. Despite the fact that drone technology has advanced by leaps and bounds in that period, navies and air forces have been sluggish to investigate pilotless jets, both because of the expenses and risks as well as cultural factors. For instance, pilots from the United States Navy successfully lobbied to have a proposed carrier-based stealth attack drone repurposed as a tanker to refuel manned aircraft. As a result, sixth-generation concepts are pushing the concept of an optionally manned aircraft that can fly with or without a pilot on board. This has the disadvantage of requiring additional design effort to develop an airplane that will still have the drawbacks and high training costs associated with a manned aircraft. However, optional manning may help ease the transition to an unmanned fighter force and, in the short term, allow military officials to deploy aircraft on high-risk missions without endangering pilots' lives. Furthermore, sixth-generation fighter jets possess sensor fusion with friendlies on the ground, sea, air, and space. One of the F-35's most notable features is its ability to absorb sensor data and communicate it to the friendly forces via data links, resulting in a composite picture. This might allow a stealth aircraft to ride point and hunt down foes, while friendly forces maneuver into opportune positions and sling missiles from further back without even turning on their radars. Because this tactic promises to be such a force multiplier, fused sensors and cooperative engagement will become a standard feature of sixth-generation jets, and the fusion will likely be strengthened by incorporating satellites and even drones deployed alongside jet fighters. However, sensor fusion and optional manning suggest that sixth-generation jets will rely significantly on data links and networks that may be jammed or even hacked. Ground-based logistics networks, such as the Autonomic Logistics Information System on the F-35, promised huge efficiency gains, but they also expose even landed aircraft to potential cyber attack. Moreover, the sixth-generation avionics systems must not only be resistant to electronic and cyber warfare, but they may also be capable of launching such attacks against adversaries. The Air Force has successfully demonstrated the potential of the Navy's fighter-borne next-generation jammer to infiltrate networks and insert data packets. But the problem is all of these sensor, communication, and weapons systems have become so complex that they risk exceeding the human brain's task processing capacity. Remember, the pilot also has to fly the plane. While some fourth-generation stealth fighters included a backseat weapon systems officer to assist, all fifth-generation stealth fighters are single-seaters. As a result, air forces are turning to artificial intelligence, AI, to perform the more routine aspects of fighter control, such as determining which data should be delivered to the pilot. Furthermore, drones could also be coordinated using AI and machine learning. In a test over China Lake in October 2016, two FA-18 Super Hornets deployed 103 Perdix drones. Animated by an AI hive mind, the drones swarmed down like a cloud of locusts over a predetermined target point. The kamikaze drones became an example that they have previously been deployed in combat, and it's simple to see how such a small and inexpensive weapon could become extremely terrifying. Future warfare theorists believe that a small number of inexpensive and well-protected weapons platforms and missiles will be significantly more difficult to defend against than a large number of expensive and well-protected weapons platforms and missiles. However, larger, faster, and fancier drones will most certainly be used as sensor-carrying scouts, weapons platforms, and decoys by sixth-generation aircraft. However, swarms of drones, missiles, and even outmoded jet fighters have the potential to overwhelm a sophisticated stealth jet's offensive and defensive capabilities. In conclusion, a sixth-generation fighter is a conceptualized class of jet fighter aircraft designed more advanced than the fifth-generation jet fighters that are currently in service and development. With the abilities and the capabilities having by the sixth generation, such as the larger airframes, more efficient engine, optionally manned, and possess sensor fusion with friendlies on the ground, sea, air, and space, might be replaced the current F-35 fifth-generation fighter jets. That's all for today. Thank you for watching, and I'll see you in the next video.